Binary search tree. Basically, binary search tree is a non-linear as well as a very important tree concept in data structure. Now, binary search tree has some following properties, and the properties are: the left subtree of a node contain only the lesser value, and the right subtree of a node contain the higher value, and the last one but not the least, that is the left and right subtree of each node must be a binary search tree. Now I am going to discuss the pictorial representation of a binary search tree and discuss the above point. This is the diagrammatic representation of a binary search tree. Now in the above point, that is the left subtree of a node contain only the lesser value. It means that if this is the root, so the left subtree means this portion, so this portion contain the lesser value. That means 3 is the lesser value than 8. That's why here 3 is considered as a left subtree, as well as 1 is also less than the value is 3. But according to the second point, that is the right subtree of each node contain the higher or greater value. Now in this example, if 3 is a node, okay, now the right subtree, that is the 6th value, contain the higher value than the root, okay, according to the BST rule, that means a binary search rule. Now if 6 is the subtree, now if 6 is the highest node or root node, now in that case 4 is the left subtree of 6, that means the lesser value, and 7, that is the higher value, that means the right subtree of the 6. In that way, if we consider the whole tree, in that case, if 8 is the root value, 3 is lesser value than 8, that's why this is the left subtree. And when we consider the right subtree, that means we consider the greater value than 8, that's why here we consider the 10. Again in the similar way, we consider the 14, that means the greater value than the 10 value, that means this is the right subtree. Again we get the 13 value in the left hand side of a 14, that means the lesser value than the 14, that's why 13 is also considered as a left subtree. And the final portion or the final point is that left and right subtree of each node must also be a binary search tree. That means according to this point, this is also a left subtree, this is also a right subtree, and as well as this is also a binary search tree, because we already discussed that this is, if this is the highest node or root node, then this 1 is the left subtree, 6 is the right subtree, according to our binary search tree formula. Okay. There are 4 basic operations performed in binary search tree. The first operation is searching, second one is insertion, third one is deletion, and the last one is traversal operation. Now for example, if we consider this is a binary search tree, in that case if we perform the searching operation, for example here we consider the 60 node position. Now 60 is the left subtree position, that is the left side of that tree. Now second operation, if we consider the insertion operation, in that case if we insert a node that is 95, then what is the position of 95? 95 value, that is it is greater than 80 as well as greater than 90, but in that case the right side node value is, here we see that 110, but 95 is less than 110, that's why its position is left hand side of 110. Okay. So in that way we perform the insertion operation. Next operation is deletion operation. In that case, if we want to perform or want to delete a particular node, for example here we want to delete the node is 10, here we just delete the node. Okay. Next operation that is performed is traversal. Now when we consider the traversal operation, in that case we perform another 3 operation under the traversal operation. Okay, the operations are pre-order traversal, in-order traversal, post-order traversal. The pre-order traversal defined as, at first we have to visit the root node, then we have to move to the left subtree, after that right subtree. Here one pictorial representation is given. In that case we have to perform the pre-order traversal of a tree. Now according to formula, at first we have to visit the root node. Now here what is the root node? That is, the root node value is a. That's why at first we have to write here the value is a. Next move to the left subtree. In that case we also consider the root node. The left subtree root node is b. Okay, that's why after that here we write b. Now left node is d, that's why here we write d. Next move to the right node or the right subtree, that is the e. And what is the left subtree of e? That is I. Next move to the right position, that's why here we write the value is c. Next the left value is, or the left side value is f. Next move to the right subtree, that is g and j. So according to the formula, this is the root node, then left subtree, after that right subtree of that tree. Okay. Next concept is in-order traversal. In in-order traversal, at first we have to move to the left subtree, after that root position, and the last or the second position we have to move to the right hand side of that tree. That means when we calculate or when we perform the in-order traversal of a tree, that is defined as, for example, if we consider this is a normal binary search tree, and in that tree if we want to perform the in-order traversal of a tree, according to formula, at first we have to move to the left subtree. So what is the left value of a left subtree? That is d. That's why here we have to write the d. After that the root position, that is b. Next move to the right hand side position. In that case we have to move to the first left hand side position, after that root position. That's why here we write I, after that e. Next left subtree is complete, then move to the root value, that is a. Next move to the right hand side of the position. In that case we also consider the left position, root position, right position. That's why here we have to write the f after that root value, that is c. Next here we consider the left value, but there is no left value is present. That's why here we write g. Then move to the right value, that is j. That means if this is a left subtree, this is root, and this is the right side of that tree. Okay. Next concept is post-order traversal. Now the post-order traversal defined as, in that case at first we have to move to the left subtree, after that right subtree, then root position. Okay, that means if we consider this is a binary search tree, in that case if we perform the post-order traversal of that tree, according to formula, at first we have to move to the left subtree. So what is the left position of that left subtree? That is d. That's why here we write d. After that right position, that means the what is the right subtree value? That is the I. Next move to the root position. So what is the root of that I? That is e. That means left position complete, left subtree complete. After that right subtree complete, then move to the root position of that tree, that is b. Again according to the formula, left subtree is complete, after that right subtree, then move to the root position. Okay, so when we consider the right subtree, what is the left subtree value of that right subtree, that is f. Then what is the value of right subtree, least value is j, because there is no left subtree, that's why we have to move to the j value, that is right position of that tree. Then root value g. So the left subtree, right subtree is complete. So after that, according to formula, we have to move to the next root position, that is c. So the left subtree complete, after that right subtree complete, and finally we have to move to the root position of that tree. So what is the root value of that tree, that is a. So this is the left subtree value, this is the right subtree value, and this is the formula, this is the root. Okay, so according to this post order traversal, at first we have to move to the left position, then right subtree position, then move to the root position. Okay, after this we have to cover the traversal of that tree. Okay, thank you.